Hello, I'm gonna ask to leave the classroom now. Quiet, look quiet. I already know. All right, guys. So good afternoon again. So this is second day in our revision. And we're gonna be revising right through the holiday, right? So you don't have any Christmas basically. You know that, right? But that cannot be that because of the Christmas holiday, you forget everything and come back January, all full of food and empty of the maths. Can't afford for that. So we're gonna be practicing right through the holiday. So we'll finish this worksheet. I'm gonna send another page in the group, and you are to complete that page for class on Thursday. All right? For class on Thursday, you have to complete those questions. I'll tell you which ones to do. Maybe half of it. I'll tell you which ones to do. And then after that, we're gonna be practicing from some past papers, right? Also, multiple choice is a good way to practice all the topics. So what you'll find, I'll be sending multiple choice papers to the group. And as you do them, I'll send you the answers and also send you solutions where I have solutions. All right, so I wanted to do those questions and get comfortable with them. All right, so we're continuing today with 4 more questions. And the reason I'm only doing 4 questions is that I want it to be a quality session. With 4 questions, I believe that you can hold a focus for the entire time that we're doing these 4 questions. All right, so I'm not going to rush it through. And then we'll do maybe another 4 questions in the next class. All right, so we have gotten to these questions. I hope you all watched the video. Those of you who were not here, where you were not here yesterday. So those of you who were not present in the class yesterday, I hope you watched the video. And I hope you're redoing the questions that you got wrong or doing the questions that you did not do. That is the whole aim. At the end of the day, you have to do these questions by yourself. So we did these first 4 questions yesterday. I want us to do 4 questions today. So we're going to do this linear programming, the simplified basic matrices question, and then we're going to go over to page 3. We're going to do this transformation, and then we're going to do these vectors and call it a day. All right? And then I'm going to send this page into the group, and I'm going to do it the same way. 4 questions, another quadratic, another functions, another algebra, and so on, and another coordinate geometry. 4 questions. Then we're going to do another day, another linear programming, transformation matrices, and then these vectors over here. Looks familiar. I think we did this one already, so I might have to do another one. And these vectors over here. All right, so that is the plan. That is the plan. So let's get through these 4 questions today, guys. Starting with this linear programming right here. All right, on this revision document. After this, we'll be doing full exam past papers for the remainder of the period. All right, so let's go. So question says, Miss James buys X calculators and Y folders. I didn't test. Persons online, can you hear me? Just making sure. I always have to make sure.
Quality.
I can see the screen. Beautiful. All right. So there are X calculators and there are Y folders that are sold at a school. So this is a linear programming question. Remember, you don't know X and you don't know Y. So X represents the number of calculators. Y represents the number of folders. You don't know how many calculators. You don't know how many folders. But there are going to be constraints, limitations and constraints around buying these calculators and folders. I have to write these limitations and constraints as inequalities. And most times we have to represent these on a graph that will produce a a common region that satisfies the conditions, all right? And then there's some other stuff they'll ask you. So the first part is telling us that she must buy at least 5 calculators. The number of calculators is X. So if she must buy at least 5 calculators, it means that the number of calculators must be 5 or more. At least 5 means 5 or more. So let's set it up. So it's X calculators and Y folders. X calculators and Y folder. Let me zoom this up. Make it smaller. All right. X calculators and Y folders. All right. So the first condition there is that you must buy at least 5 calculators. Means that the number of calculators X must be greater than or equal to 5. At least 5 means 5 or more. If you can't remember what at least means, just think of money. If you must have at least $5 to do something, it means that you need 5 or more dollars. A lot of persons see the term at least and associate with less than sign. Just see the word least and put the less than sign. Just interpret the language of the statement. At least 5 calculators means you must have 5 calculators or more. So that's the inequality for the first condition. Here now is the second condition information. It says the number of folders she buys, remember the number of folders is Y, must be at least twice. At least again means more than, greater than or equal to. At least means that amount or more. So the number of folders Y must be at least twice, meaning 2 times the number of calculators X. So that means the number of folders, second condition is that the number of folders Y must be at least, meaning greater than or equal to, twice the number of calculators. Remember, number of calculators is X, so twice that amount is 2X. That's the second inequality. Y must be greater than or equal to 2X, at least twice that number. And that's the second inequality we are told to write. What are we good with that? Oh, good. So now they're giving us some information about money, right? So I like to bring money into the play here. So it says the cost, a calculator costs $20. That means 1 calculator. So let's set up a cost profile on this information. So I want to put in a section for the cost. So the calculators is $20 each. $20 for 1. Remember, she buy an X, you know. So the total she's spending on the calculators is 20 times X. And for the folders, it is $5 each. It says that folder costs $5. So the folders is paying $5 each, $5 for 1. And she's buying Y folders. So the money she's spending on the folders is 5 times Y. All right? If it was 2 folders, it would be 5 times 2. If it was 3 folders, it would be 5 times 3. It is Y folders, and so it is 5 times Y. All right? It says she only has $300. Miss James only has $300. It means that she cannot spend more than the $300. So the total that she spends to buy the folders and the calculators will have to be $300 or less. Is either she spends all of it or she spends less than it. She cannot spend more than the $300. So the total amount that she spends, an expression for the total amount spent, is the money that she spent for the calculators, which is 20X, plus the amount that she spent for the folders, which is 5Y, and that total amount spent has to be less than or equal to the total that she has. She only has $300. So we're going to put the 300. And we don't need to put the dollar sign. It will cancel out itself. And then this can be simplified by dividing through by the 5. So divide this by 5, we're going to get 4X. Divide this by the 5, we're going to get Y. Divide this by the 5, we're going to get 60. So this is really your inequality that you're going to put on the graph eventually, a simplified form. So that's inequality. So you don't want to leave this, you know, this is still correct, you know, but always simplify into lowest terms, and you're expected to simplify into lowest terms at all times. So we have 3 inequalities there, and so we expect a triangle, 3 lines, one associated with that, one for that, one for that. And so our region is supposed to be a triangle. All right, it says now here is to draw the graph. Using a scale of 2 centimeters to represent 5 calculators on the x-axis and 2 centimeters to represent 10 folders on the y-axis, draw the graph of the lines associated with all inequalities. And then here, we are told to shade the region which satisfies all inequalities. That's a common region. So let's do that part first, part 4. All right, that's the part 4. All right, so let's write how we're going to represent each of these inequality on the graph now. All right, just remind ourselves of how we represent each inequality on the graph. Now, this that I'm going to write now, you don't need to write it. But this is supposed to be your chain of thought, right? In terms of representing on the graph. So this one here, or this one. Remember, an inequality on a graph is about being above or below a line. That's what inequality on a graph is. Either being above a line or below a line. You want the region that's either above a line or below a line. When the equal is there on the inequality, it means that you also want the line. The line is a part of the inequality. Generally speaking, greater than means above the line, less than means below the line. But equations like this or expressions like this that has the x and the y in it is going to give you a graded line. Slanted up like that or slanting down like that. When that is the case, to decide whether you want above or below the line, or put another way, for less than to mean below, the y on the left side of your inequality has to be positive. Remember that. The y on the left side of your inequality has to be positive for less than to mean below and for greater than to mean above. All right? So we have to remember that, guys. All right, so for this one now, that's a greater than sign. And the greater than means above in this case. It's going to go above this line. The line is going to be drawn solid, meaning the line is a part of the inequality because of the equal. So we're going to be drawing a solid line. And the line that we're drawing is the one associated with this inequality, which is just the line x equals 5. Just replace inequality sign with the equal sign and you have the line. So that line is x equals 5. And you almost know that x equals 5 is a vertical line passing through 5. All right? So we're going to be drawing the line x equals 5. We're going to be drawing it solid. And above a vertical line means that we want to the right of the line. We want where values are of x are greater than 5. All right? Then for this one, the y over here is positive, and so it's greater than means above. The y is on the left side of the inequality, and it is positive. And so this greater than sign means above. So for this one, again, we are going above a line. I always like to write above or below first because the inequality is really about that, being above or below. So that's the first consideration. Then the next thing is whether the line is drawn solid or broken. The line is drawn solid when the equal is a part of the inequality. The line is drawn broken when the equal is not a part of the inequality. So when the equal is not a part of the inequality, for example, if this equal was not there, if that equal was missing, then you would draw a broken line, meaning then that the line is not a part of the inequality. You would only want then the region above the line. All right? But this one does have the equal on it, and so we're going to be drawing the line solid, meaning the line is a part of the inequality. So we're going to be drawing a solid line, an unbroken line. And the line we're drawing is one associated with this inequality line y equals 2x. And so this line, because there's no c value on it, you know it's going to pass through the point 0, 0. Let's just put on 2 points quickly. And it's going to pass through a point where the y value is twice the x value. So for example, if the x value is 10, the y value is 20. We can use larger values as well. If the x value is 20, then the y value is 40. Because 2 times this x value gives you the y value. So if you pass through these 2 points, we'll only need 2 points. Then we come to this third inequality here. Right? Remember, everything I'm putting in red, you don't have to do. You don't have to write out this on the paper. I'm just saying these are the things that you should be thinking about when you're going to be drawing your graph. All right? This is your chain of thought. All right. So for this one now, again, the y on the left side is positive. And so this less than sign means below. It means that you want below the line. I'm giving you an easy way to interpret it. So this one means that you want below the line. Then the line is going to be drawn solid again because of this equal, meaning the line is a part of the inequality, meaning points on the line are also valid. So you're going to be drawing a solid line. And the line you're drawing is the one associated with this inequality. It's the same inequality changes to an equal sign to get the line. So it's 4x plus y equals 60. And so now we need 2 points on this line. We need 2 points on this line. So a quick way to get 2 points on this line is to make one of them have an x value of 0 and the next one a y value of 0. Now for the one where the x value is 0, it's like you put the 0 here, so this will be gone. And you'll be left with y equals 60. So when x equals 0, the y is equal to 60. And so it is 0, 60. But I go to that. And by the point where y equals 0 is like this 0 becomes the y, so the y will be gone. You'll then be left with 4x equals 60. And so if 4x is equal to 60, you divide by the 4, the x will be equal to 15. And so when the y is 0, the x is 15. And so that is it. So we're going to put 15 here. So these are your 2 points, quick and fast. So always a nice quick way to get your 2 points. So these are the 2 points we're going to use to draw this line on the graph. All right, so let's go now. Let me just put this up here. Put this information over here and then draw the graph. Let me just copy this over here for the time being and draw the graph. All right. Let me draw the graph right here now. I'm not going to use a graph. I'm just going to sketch it, right? I'm just going to sketch it. All right. So it's y-axis, x-axis. And question said on the x-axis, it was what? 5 centimeters to 2, right? Let's look what it said. It said, it said 2 centimeters to 5 and 2 centimeters to 10 on the y-axis. So 2 centimeters is 5. So that will be 5, 10, 15, 20, 25, 30, 35. 5, 10, 15, 20, 25, 30. Every 2 centimeters. I'm putting in my 1 centimeter marks now. All right. Eventually, we're going to be doing these on graph paper. But now, let's get through it quickly. Then on the y-axis is 2 centimeters to 10. So it's going to be 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. That's the x-axis. That's the y-axis. This is 0. All right, let's put in the 1 centimeter marks now. Guys, every 2 centimeters is 10. All right. Let's draw it in purple. All right, so we're doing these graphs now. So the first one is this one, x equals 5. X equals 5 is a vertical line passing through 5. So I'm going to draw a vertical line up here. You do it on graph paper and do it straight. And then you label the line with the equal sign. This is x equals 5. And above all, vertical line is to the right. So the region that we want is to the right of that line. The next one is this one, y equals 2x. I will say y equals 2x is passed through 0, 0. I will pass through 20, 40. So like 20, 40 is going to pass through 30, 60. So 30 here and 60 up here. So 30, 60. So you're going to pass through that point as well. All right, so we can draw a line passing through there. That's a point 30, 60. And it's going to pass through 5, 10 right here. So basically our line will be like that. Label the line with the equal sign. This is y equals 2x. And that one we want above that line. Above, right? Above that line. So we're going to put the arrow pointing up. Let me take these off now. So it means that the region that we want is somewhere near right now, right? Above this one and to the right of this one. So our region is somewhere inside here. But we need a third line now. This third line. and that third inequality, which is on this line. So that line, we're using these 2 points to draw that line. So it is 0, 60 on the y-axis up here, and 15, 0 on the x-axis down here. So the straight line through those 2 points now is the third line. Like that. Then you label your line with the equal sign. So the line is 4x plus y equals 60, and we're going below this line. So you see the region that we want is actually this triangle right here now. I'm gonna color it in this, let me use this color for it. This is the triangle that we want. Right? That is the region that is below this line. Mark it like this. The region that we want is below this line that we just did, above this one, and to the right of this one. So that is the region inside here. This is the region that they told us to shade. Everybody good at that? And we also know that the vertices become very important because the vertices are the extreme, are the points where the extreme values of x and y in the region. Remember now, all points in this region, all points in this region are valid for the conditions. All points in this region are valid. And also all points on the on the lines are valid because you draw solid lines. So these vertices are the points where you have extreme values, the largest and smallest values of x and y that satisfy the conditions. And so if you want to calculate maximum or minimum of anything, you go to the vertices to do it. If a vertex cannot work, because for example, let's say a vertex had 2.5 calculators. You cannot have 2.5 calculators. It means that you'd have to go along the side and find a point with whole number values, counting number values that can work. But CSEC nowadays tend to set questions where the vertices can work. All right? So it's first to determine what are the coordinates of these vertices. Now, if you do it on graph paper, you will just look and know. You get me? But because of this now, I can't just look and know, so I kind of work them out. So this one right here is 5, 10 for sure. Because it's on the line where y equals 2x, and it's on the line where x equals 5. So this point right here is 5. Let's call it A. Let's call this one B. Let's call this one C. I'm going to write A is a point, 5, 10. We need the vertices. We know we're going to need them. This one. It's x equals 5, and it's also on this line. So if we put x equals 5, it's actually 540. So B is a point, 540. Because if we put the 5 right here, it's going to become 20 plus 40 makes 60. So yes, the y is 40 at that point. And then here now looks like 1020. This looks like 1020. C looks like 1020. We can check it. 1020 is good for this line. But the y value is twice the x value. But let's test it on this line now. 1020. Yes, it is correct. Because 4 times 10 plus 20 add up to 60. So yes, this point is correct. If you do it on graph paper, you wouldn't have to be doing this check once you draw the lines correctly. So those are the vertices. So I'm going to copy these vertices over here because I know I'm going to need them. All right, let's leave it there for the time being. But let's get back to the question now. So that's a graph, guys, and the shaded region. But good? But good?
Yes, sir.
All right. All right, so when you do it, I want you to do it on graph paper. Do it on graph paper. All right, so we have that region. Let's see what they want us to do now. So I've done this part, and we have done the graph. All right, so the next part now is telling us about profit, right? It says the profit on a calculator is $6. Profit on a folder is $2. Write an expression for the total profit. So look at the profit profile up here. Let's put on in blue. Profit now. It is $6 on each calculator. It's $2 on each folder. So the total profit on the calculators is 6 times X, and the total profit on the folders is 2 times Y. Because X is the number of calculators, Y is the number of folders. So if it's $6 on each calculator, and there are Y calculator, there are X calculators, sorry, then the profit on calculator is 6 times X. If it's $2 on each folder, and there are Y folders, then the profit on the folders is 2 times Y dollars. So the total profit is 6X plus 2Y dollars. All right, so that's the expression that they want here. Write an expression for the total profit P. All right, so let's go. So, all right, on here now for part 5, total profit. We're going to call it P dollars, such that the P becomes 6X plus 2Y. Very good. That's the expression for profit, for the total profit. This is the profit on the calculators. That's the profit on the folders. You add them to get the total profit. All right? So that part is now finished. Next part now says, an expression. Well, I call it this. I don't think they'll penalize if you do it that way, but this is really expression. All right? That is good. Right? That's the expression for the total profit. So if you just write this, they give it the marks. But I call it P. It's because they say a total profit P. That's why I set it up like that. But it's not in either here nor there. All right. The next part now says, using your graph, write down the coordinates of the vertices. See? I didn't even know they asked that, but they did. Because all these questions, they will always want that. So let me just copy this down and put it down here. They will always want the vertices. Those are the vertices, A, B, and C. And the next question is what they'd like to ask is calculate the total, the maximum profit, sorry, maximum profit. So the maximum profit is at one of those vertices. I don't have to test all of them. Let's look at it. So you know that this one definitely cannot give you the maximum profit. This point A cannot give you the maximum profit. Because the values of X and Y, they are lowest. That's where you're actually going to get the minimum profit. So it don't make sense to try that one. So the maximum profit is either at B or at C. And don't get into the habit of trying to look and know. Test them. Test each of those 2 points now to see which one actually going to give you the maximum profit. Why is it good to test? Because remember that this one has more Y value, more in terms of the Y values. And this one has more in terms of the X values. Right? So the good thing to do is to just not look and assume, but you calculate on each of them. And sometimes the question will say, justify your answer. And they don't want you to just look and guess it. But you actually calculate the profits. You have to use one of these points. It's either B or C. So we're going to test for maximum profit down here. So for part 7, let's do the test in red. Test for maximum profit. We're going to test the point B first, which is 540. So you put in the 540 in this profit formula. So the profit at B will be 6 times the X value, which is 6 times 5, plus 2 times the Y value, which is 2 times 40. So this is actually 80 plus 30. 80 plus 30 is how much? 110. So your profit, if you operate at B, is going to be $110. If you operate at C, which maybe, if you operate at C, where you have 10 calculators and 20 folders, your profit at C is going to be 6 times, see there, using the formula, 6 times the X value, 6 times the X value, 6 times 10, plus 2 times the Y value, 2 times 20. Now this is 40, and that is 60, so this is just $100. So you're actually getting more at this point. So that's where you're gonna get your maximum profit if you operate at point B. All right? So you're gonna draw the conclusion and say, therefore, maximum profit is, and you put the dollar sign on it, $110. You can tell them conditions. When you sell 5 calculators and you sell 40 folders. And that amount are sold. And that is it. But good? Just a young lady for me. Stop sleep. Can't sleep and learn nothing. Christmas come too early. Come wake up, man. Remember, guys, if you go and do these questions over, if you never do them, you know. These are the questions coming in the exam. These are past paper questions. Get comfortable with them. They basically ask you the same thing all the time with different numbers, different values, different conditions. All right? Practice them. I'm going to share the video to the group. You use the video to assist you to do the question on your own. Just speak with these questions. If you master just one, just get through one on your own. The rest of them you can do, you know. And sometimes I say to the student, do the same one question 5 times repeatedly until you can get it through by yourself. If you have to do it 5, 6 times, just do it over and over again until you can do it straight through from beginning to end by yourself. They find the rest of them now become easy because the same things they tell you in all the questions. This one talking about calculators and folder. Next one going to talk about pen and pencil, a book and pencil, a shirt and pants. It's just the same kind of thing all the time. Violins and guitars, apples and grapes. Just have all these questions set up all the time. To get a good bargain, the person must buy at least 10 cars, must rent at least 10 cars, cars and vans rental. It's the same thing all the time. All right, come on. All right, but go online. I tend to forget the people online all the time. But go online.
Yes, sir.
All right, beautiful. All right. So I'm going to make this a nice efficiency. 1 down, 3 to go. This one is a very easy question. Quick and fast. Major C's question, not even transformation in this one. Straight major C, this one. Let's get through it. All right. So this question gives us this matrix, and it tells us that it is singular. Stop talking. Stop talking. Hey, may I run out of the class, you know? They tell us that it is singular. So it is singular, meaning, remember, singular means it has no inverse. Don't forget that, because sometimes instead of saying it is singular, the question could have said it has no inverse, which means that it is singular. All right? So it is singular, meaning it has no inverse, has no inverse. And when it has no inverse, the determinant of the matrix is equal to 0. And this is a key thing that is used for the calculation. Determinant, well, hello. You don't want no talking. Talking and recording don't go well together. Not disturb on your own self. But no, listen back to it now. If you do listen back to it, I want to say, I'm going to disturb on yourself. So we're talking, man. Don't chat too much. All right. Ready? So give us the matrix. D equals 1, 9p, p4. And they tell us that it is singular. It simply means that the determinant of the matrix is equal to 0. Determinant of D is equal to 0. I could write it like this as well. The determinant of D. This is another way of writing determinant. Is equal to 0. All right? That's another way of writing the determinant. All right? So remember that, just in case I put it like that for you. All right? I see in question already where they tell you that the determinant is 0 and they ask you what kind of matrix it is. It is a singular matrix. All right? So they try to twist this thing all different people. Remember, when the determinant is 0, this product becomes equal to this product. And look at the key thing here now. This question to determine the values, plural. It's a value of value, but this will actually have values. Values meaning plural. And it's going to test your knowledge of the square root of a number. Come on, remember when you calculate square root, it can be positive or negative. Come on, we have to get past that hurdle now. A lot of the time, the values thing come about because people forget that when you calculate square root, it can be positive or negative. Remember that, please. There are certain things that there'll be nothing there to help you, you know, just your own brain, just your own brain, just what is in your head gonna help you. Just like the inequality, we say we divide an inequality by a negative number, you have to reverse the sign. There's nothing to help you to remember that. Nothing to guide you to remember that. That'll be in your head. Same thing with the square root business now. When you calculate square root, you have to remember that it can be positive or negative. Come on. Ready? So this one, determinant is 0, so it means that this product minus this product equals 0. Or another way to put it, this product becomes equal to this product. So when the determinant is 0, the diagonal products equal as well. So it means that this product, which is the 9p times p, which becomes 9p squared, is equal to this product, which is 4 times 1, which is 4. Or, let me do it the other way. The determinant would have been this product, the first diagonal product, which is 1 times 4, which is 4, minus this product, which is 9p times p, which is 9p squared, is equal to 0. And you're solving this for p. So you can take this and transpose it. It's going to become 9p squared equals 4. You divide away this 9. I'm going to do this another way and show you. Could divide away this 9, and then you will get p squared equals 4 over 9. Then to get out of this square, you're going to square root. This is where you know you have to remember that square root is plus or minus. So you're going to put the square root of 4 over 9, but it's either plus or minus. That is equal to the p. Square root of the 4 is 2, square root of the 9 is 3. So this actually becomes p is plus or minus 2 over 3. That's the answer. P is 2 or plus, i.e. that is P equals 2/3 or P equals minus 2/3. Let me do this part another way and show you right here. So those are the two possible values. We could do it at the difference of 2 squares, you know, look. We could do this at the difference of 2 squares right here. We could treat this as the difference of 2 squares. Write this 4 as 2 squared. Minus, write this 9p squared as 3p all squared equals 0. That's the difference of 2 squares, and it will factorize as the difference of 2 squares. So you factorize this as the difference of 2 squares, it becomes 2 minus 3p, 2 plus 3p equals 0. Then either this factor equals 0, so you're getting 2 minus 3p equals 0, or this factor equals 0, which is 2 plus 3p equals 0. If I transpose this 3p here, I'm going to get 3p equals 2, and then divide under the 3, you get p equals 2 over 3. Or, using this one, we could transpose the 2 and get 3p equal negative 2, and then divide under the 3 and get p equals minus 2 over 3. So that's how we could get the two answers another way. But this one kind of proves it that is really two answers you're supposed to get. But most persons would have approached it this way, which is to divide away the 9 and then square root. And a lot of people are going to forget the plus or minus. You don't have to remember it in this class. You're not busy what other people want to do. You don't have to remember it. When you calculate square root, it's plus or minus. That's what the values usually come about in these questions. All right? Very good?
Yes,
Online,
sir.
very good? All right, beautiful. This one now says, given this pair of simultaneous equations, they want us to use a matrices method to solve them, right? So using these, solving these with a matrices method. Let's set it up here. So firstly, the two equations are 2x plus 5y equals 6 and 3x plus 4y equals 8. So to use the matrices method, I have to first write this pair of simultaneous equations as a matrices equation. All right? It's quite simple. Once you have the x value followed by the y value, in both equations, which they do here, then it becomes a 2 by 2 matrix times the same column matrix XY equals a column matrix 6, 8. And then to populate this 2 by 2 matrix, you're using the coefficients on the two equations. So the first equation is 2, 5, 2 and 5. And the second equation, it is 3, 4. 3, 4, and some people still at I run them out of the classroom. Then to make XY the subject, remember now, it's a simple, basic matrices transposition. The inverse of this goes onto the front of that on that side. Why does it go to the front? If it's on the front on this side and you transpose it, it must go on the front on the other side because matrices multiplication is non-commutative. Matrices multiplication is non-commutative. So the inverse of this must go on front to leave this XY as a subject. So let me set it up for you now. So the XY on the subject is going to become the inverse of this matrix in front of the 68. 2, 5, 3, 4. Let me put the -1 on it. It is the inverse. It's done in red. It is the inverse of the matrix, not the matrix, the inverse of it. We're going to have to work out the inverse. I'm multiplying that now by the 6, 8. So we have to work out this inverse. All right? So the inverse of that matrix now is 1 over the determinant multiplied by the adjoint. Inverse of this matrix is 1 over the determinant. What is the determinant? It's this product minus this product. The first diagonal product, or the leading diagonal product, or the primary diagonal product, or the main diagonal product. Anywhere that means first is this diagonal. That's 2 times 4 is 8. Minus the second diagonal. Some people say the trailing diagonal, or the following diagonal, or the secondary diagonal, or the second diagonal. Anywhere that means second, anywhere that means not the first, is this diagonal. That's 3 times 5 is 15. That's a determinant on the here. 8 minus 15 is -7. So the determinant is actually -7 on there. I multiply that now by the adjoint of this matrix. The adjoint matrix. How do we get the adjoint? Interchange the elements on that first diagonal. Switch them around. Just trade the places. That's all they do. So you put the 4 here and the 2 there. Then these 2 elements on the second diagonal, you're going to leave them where they are. But you change the sign of those 2. So these first 2, you don't change the sign in it. You just switch them around alone. And this second 2, you don't switch them around, you just change the sign. Some people confuse what we do all the time. Pay attention to the details. Everything important. First 2, you switch them around alone. Don't change the sign of the first 2. The second 2 and the second diagonal, you leave them where they are, and all you do to them is change the sign. If it's positive, you turn it negative. If it's negative, you turn it positive. If it's 0, it stays 0. 0 is a neutral number, neither positive nor negative. Good. So this 5 stays where it is, it's going to become a -5. This 3 stays where it is, it's going to become a -3. This here is the inverse matrix that we just did. That's the inverse. We are multiplying it by the 6, 8. So multiplying that by the 6, 8. All right, music stops. So a little bit easier now. Now, this is 1 over -7. I always say to the students, don't bother put the -7 inside here yet. Work out the whole number of values in these 2 matrices first, multiply them with the whole numbers, and leave the 1 over -7. Leave the fraction for last. Because oftentimes, when you do the multiplication in here, you're going to get some multiples of the 7. Oftentimes, that's what happens. All right? So let's do it. So it's going to become equal to 1 over -7. That's the determinant. And now we are multiplying these 2 matrices. How you multiply the matrices now? Remember, we multiply a 2 by 2, with a 2 by 1. You're getting a 2 by 1 with 2 values. All right? To get this first value up here, you're going to multiply this row by this column. First row by the first column, because that's the position of this value. It's in the first row and the first column. So to get this value here, you multiply those two that I've marked, this row by this column. How do you multiply the row by the column? You multiply the first element in the row by the first element in the column. Then you multiply the second element in the row by the second element in the column. So we say first element times first element, second element times second element. Good. All right? That's our little song that we use to remember. First element times first element, second element times second element. First element times first element, second element times second element. So it's 4 times 6 and negative 5 times 8. 4 times 6 is 24. Negative 5 times 8 is negative 40. That's all? Negative 40. 8 5 is 40. So far, so good?
Yes, sir.
Good. Then the second value down here is positioned in the second row and the one column. So to get it, we multiply in this second row by this one column. Multiply the same way again. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. Negative 3 times 6 is negative 18. 2 times 8 is 16. So this time we don't get the multiple of the 7. No matter what you get is what you get. You're not sure you can test the values in the answer. So the xy reduces to 1 over negative 7 times, this becomes what? Negative what? 16? Negative 16. This one becomes what? Negative 2. So you divide each of those values now by the negative 7. So this negative 16 divided by this negative 7, the negatives cancel, you get 16 over 7. This negative 2 divided by this negative 7, okay, negatives cancel again, I get 2 over 7. All these values look familiar, so. And then now, you're going to write the values. Don't just leave the matrix as the answer. That's not the answer. The answer for the simultaneous equation is when you state the value of x and state the value of y explicitly. So the x is equal to 16 over 7. And the y is equal to 2 over 7. This is the answer right here. All right? So when you write them like that, write out the values, you get the answer. The question didn't ask for a matrix, it asked you to solve the equation. To solve the equation is to state the value of x and state the value of y. That is simultaneous on the two equations. All right? Very good?
Yes, sir.
Lovely, lovely. So remember, if you never do it, go and do it. So 2 down, 2 to go. Yes, I think we're gonna have a lot of fun on the last one that we're doing today. This vectors question. We're gonna have a lot of fun on that one. But let's do this transformation here now. Let's do this transformation right here now. This one. All right, this small up to here. All right. All right, so this transformation question, it says on the answer sheet above, ABC is mapped onto A prime, B prime, C prime under a reflection. So they're telling you what it is, a reflection. It says we are to write down the equation of the mirror line that takes us from this to this. So the mirror line is going to be on the perpendicular bisector of the line joining. Yeah, perpendicular bisector of the line joining corresponding points. So C to C prime is halfway between them. And A to A prime is halfway between them. So it's clearly, I mean, sometimes this thing too obvious. Sometimes easy things are hard to explain, you know. Don't it? Yeah. The mirror line must be right halfway between them here, so don't it? Don't it? A vertical line passing through 5, just need to make sure you write x equals 5 and don't put y equals 5. Vertical lines carry an equation, x equals a number. If you don't remember, just check out the y-axis. The y-axis is always x equals 0. The vertical lines at the y-axis is x equal a number. Can't go wrong. If you don't remember if it's x equals or y equals 0, let's go to the y-axis. The y-axis is not x equals 0. The y-axis is not y equals 0. The y-axis is x equals 0. Because all points on the y-axis, the x value is 0. That's why it is x equals 0. And the x-axis is y equals 0. The x-axis is y equals 0. So any line horizontal like the x-axis is going to be an equation y equals some number. All right? And you can know what number it is by what it pass through. So if you pass through here, so this line is y equals 2. Because it pass through 2. There's y equals 2. Come on, we don't want to get them something wrong. And we don't want to get them something wrong. It's too easy. All right, so the answer for this one is x equals 5. X equals 5. First answer here is x equals 5. Vertical line passing through 5. So part 1. X equals 5. Let me say, let's write it down. Let's write it down. After doing a calculation now, let's write it down and get your mark and go on. All right, let's write down the equation. X equals 5. Next part now says the prime triangle. That is this one. This one now. Where the prime one there? This one. That's the prime one. The prime one is mapped to a double prime one by a 180-degree rotation about the point 54. Yes. I like this one. So we're doing a 180-degree rotation about a point that is not the origin. So remember, when your rotation is not the origin, you cannot use any of the matrices that we know. The matrices for rotation that we know is when the center of the rotation is the origin. So the matrix of 180-degree rotation about the origin is this one. -1, 0, -1. That one is for rotation about the origin. Since this one is a rotation about the point 54, you're going to have to construct it. And a good way to construct this is to remember and recall that to do a 180-degree rotation about a point is the same as just reflecting through the point. Treat the point like a mirror. If you try to actually construct the rotation, you might run into problems. So the quick and easy way to do a 180-degree rotation about a point is to instead reflect through the point. See it here, you have a point right here, so. And I have something up here, so I rotate. This is my center point. I'm going to rotate this around it over to there, so. Right? It is easier to just think of it as reflecting through that distance and the image distance. Them two distances are the same on the same straight line. Treat the point like a mirror. The end result is the same. Those things you're going to exam armed with the knowledge of in your head. That's why we do it in the class. Because we know it's a question like this is on the exam paper. Don't try to do the rotation. You run into problems. Just reflect each point through the center point. Treat the center point, the center of rotation like a mirror. All right? So that point is a point 5. That point is a point 54. 54 is right here, this point. All right? This point right here is a point 54. And we do have to do a reflection of this node tree. Let me take out this red line so don't confuse us. So we're doing a reflection through this point to get the 180-degree rotation of this triangle, right? Image distance equals object distance. Look what's going to happen. Let me zoom up on it. So this point A is 1 unit to the mirror line, to the mirror point. The image goes 1 unit on the other side. So A double prime is right here now. A double prime is right here. Let's pen the thinner. Right. 1 unit to the mirror point. It's going to go 1 unit on the other side of the mirror point. So the image point is here. That's A double prime. Then this point B is how many? 1, 2, 3 units. It's going to go the same 3 units on the other side. 1, let me do it like this. 1, 2, 3 units to the mirror point. It's gonna go 1, 2, 3. So yes, it's coming here as well. That's B double prime. It's coming here. So those 2 points go back to the same place. So the bad point I know this one. How do we reflect this point now through here? So you can draw a straight line to there and do the same distance on the other side. All right, so I'm gonna take these off. All right, so this other line, this other point, reflect it through. So this distance down to this point, I'm going to go the same distance on the other side down to there. That's where it is going. But understand that. Now, to get that distance, to get this distance, you can actually break it down into a vertical and a horizontal movement. So for example, you can say it is 3 down and 3 back to get to the center point. So this distance on the other side is going to do the same thing. 3 down, 3 back. So this point is coming to here. And you can see if we extend this, it shows it. So this point is coming to here when you rotate it through that. All right, so it's coming to there. So these are my 3 points. Put the third point here. This is C double prime. Let me take these off now. So my triangle is this one. That's the 180-degree rotation about that point triangle. But go to that. Remember, guys, instead of trying to do the 180-degree rotation, reflect through the point. The distance from the point, from a point on the object to the center point, is the same distance on the other side. Reflect through it. Treat the center point like a mirror and reflect through it. All right, so this is the image, the double prime one. All right, let's continue. So that finishes that. Let's show it on the graph. It says now, describe now, watch this now. Describe the transformation which maps ABC onto the double prime one. Which transformation is going to map this one onto this one now? But you can tell me, which transformation is going to map this onto that?
Reflection.
You cannot just say reflection, my boss.
Reflection through the line, 3? No, 4. I mean, y equals 4.
Good. So somebody online says reflection in line y equals 4, which is correct. All right? Reflection in line y equals 4, this one. I said describe it. To describe a transformation, you have to give the name and the components. So remember, reflection in a line only has one component, the mirror line. But you can see that to go from this triangle to this triangle is a reflection in this line. A reflection in this line. But you can see that? Huh? But you can see that? That's line y equals 4. I watch the magic in this now. I'll show you the magic in this now. Watch the magic in this now. So, what happened in these two transformations? Look what happened in these two transformations. Look what happened now. From this to this was a reflection in this line. Look at it now, you know. So the reflection in this line, right? Look what happened. A reflection in this line first. That's what we did first. Come on, Mr. Shaw. A reflection in that line, right? And I will follow that up to go from this to this with a 180-degree rotation, don't it? Look what we have now. So we'll go from this to this first. First transformation with a reflection in a line, right? And then we'll follow that with a 180-degree rotation. So we have a reflection in a line, that purple line. Then we have a 180-degree rotation here, so don't it? I always tell you that two reflections, we talk about combined transformations. Two reflections go with one rotation. So the two reflections will give you a rotation, or a reflection and a rotation is going to give you back a reflection, right? So watch this now. Since the rotation is 180 degrees, what is the angle between the two lines? Because we have one line already, you know. So we're trying to determine what is the other reflection line. Because if you have a reflection and a rotation, and you put them together, they're going to combine to give you back a reflection. Because two reflections give you one rotation, right? Two reflections go with one rotation. And it can go in any order. So if you get the two reflections first, it's going to be equivalent to a rotation. If you get a reflection and a rotation, it's going to be equivalent to a reflection. A reflection and a rotation are going to give back a reflection. So since we have one reflection already and we have the rotation, we know that the other transformation that you're going to get when you combine these two, one followed by the next, has to be a reflection. What's the relationship between the two mirror lines and the rotation? So the rotation angle is twice the angle between the two mirror lines. One, that's the first thing. So the rotation angle is twice the angle between the two lines. So this rotation angle is 180 degrees. So the angle between the two mirror lines is 90. So if one of your lines is vertical, the other mirror line must be what? Horizontal, don't it? Good. The next thing is that the center of the rotation is where? Where's the center of the rotation? The center of the rotation is at the point of intersection of the two lines. This is the center of the rotation. So that's where the two lines must intersect. So the other line has to be horizontal, because it has to be 90 degrees to this, and it must pass through this point. That is why it is this line. You understand that? So you could know that that is the answer as well. So everything in sync. Your calculations and the diagram and your knowledge, everything in sync. That's why these additional knowledge is good to have. You can be satisfied with the answer like this. Because you have it now. These two mirror lines, they are 90 degrees apart and they intersect at this point. So you put these two transformations together, one followed by the next, it will give you this 180 degree rotation about this same point here. All right, so I just wanted to show you that connection. But in any case, that is the answer, right? So this was one mirror line, x equals 5. The other one is y equals 4. Y equals 4. So the answer for this one down here is y equals 4. And you could see it on the diagram. Y equals 4. All right, so this triangle reflects to this triangle by reflecting that purple horizontal line here. Y equals 4. All right. But you could have reasoned it from combined transformation. Done. Then we'll come to one more question for you. What time it is now? What time is it? Wow, now going early to them, man. Don't lucky so. Can't ask me, Sean, I go to in Christmas, you know. Huh? 6:30 now. Wow. It's 6:30 now, man. Can't say Mr. Sean, I'm not gonna go home early. All right, let's go. Let's do this one now. Vectors. And we'll call it a night. I want everybody to be attentive in the revision. I don't want to do too many questions. I make people start to sleep. All right. So they give us this diagram here, guys. It says in the diagram, M is the midpoint of ON. This point is the midpoint of that line, right? It says sketch a diagram above on your answer sheet and insert the point X on OM such that OX is 1/3 of OM. We can do it right here, so now. So OX must be 1/3 of the OM. Easy. That one is easy. So this is the OM. You want 1/3, divide it into 3 equal parts, right? So you divide it in about 3 equal parts like that. See there, 1, 2, 3. And so the X has to be around here. So don't it? That is X. Good? Are you good at that?
Yes,
all
sir.
right. Good. Then the next part says, that's all I wanted us to do. It's an easy question. Next part now says, px produced. Oh, I need to copy the diagram for true. I'm going to draw it over and put it over on the screen. Let me just kind of trace over it and then copy it over. Let me trace over it and then copy it across. All right. So it is O, this is M, Sabatar, this is N, this is P, and it gave us these two vectors on the diagram. So this one going up here is vector R. This one coming down here is vector. Hey, stop talking now. So yesterday class never give me too much talking, none at all. I'm doing. All right, so those are the two vectors. All right, so this question now says px produce. It here px is produced. This one says now produce px to q. Remember the word produce means extend, right? Told you that before, right? So px, it's a produce px means extend px, lengthen px to q such that px must be 4 times q, 4 times xq. So this is px right here. Let's draw it on a different color. So this is px. And I want us to extend it such that px is 4xq. Px must be 4xq. So px must have 4xq on it. Okay, we're going to get it now. So px must have 4xq's in it, right? 4xq's. So like you take px and divide it up into 4 parts. All right? Good. So like you take px and divide it into 4 parts. Let me just show you in black. So you divide px, the 4 parts. You divide it halfway first, and divide it half and half again. So this px is 4xq now. All right? So this is one of the xq right here. So I'm going to zoom it up for you. So one of the xq is this length right here. This is 1 xq. See that? Don't it? Got it? But px must have 4 xq's in it. So that is 1 of the xq. So if I take this, let me see if I can select it like so. I don't want that. I want to select over. I'll do this again. Oh, do you do this again? Oh, hold on. Like so. Good. So that is it. So you extend it such that xq. So this is xq now. Xq is just like this like a piece right. I'm changing it to blue for you. xq. Q is right here. You understand where q is? But understand that?
Yes,
But that's
sir.
that. So you see, you have to be able to break up stuff like that. And one way that I always say is, if px, right? Let me show you something. Just want to make sure you can get this. If px right here is 4xq, see there? Px has 4xq in it. It's like you say, okay, this has 4xq in it. And then xq must be somewhere down here. So it'll tell you that this whole length has divided into 4 parts. Each part is an xq. And so xq is just 1/4 of this whole line. You understand that? Another way you could look at it is just divide this 4. Divide by this 4. And so, okay, the xq is 1/4 of the px. So the length of xq is 1/4 of the length of the px. So you take 1/4 of this line and you extend it by just 1/4. That's where it has to go. Now practice them something here and get them right. They mess up a lot of people in now. You get me? All right. So that's where Q is. So it means that this whole line have 5 XQs in it, don't it? But I can say that. We can basically say then PQ is 5XQ. 1, 2, 3, 4, 5, don't it? So PQ is 5XQ. PQ then becomes 5XQ. 4 upon a line here plus 1 more, don't it? What is that? Good. All right. In case we need it. All right. So that's where it's positioned. Let's see what they want us to do now, though. Tell you you're going to like this question. I think I like me, I tell. Next part now says, write in terms of R and S, the vector OM. The vector OM. How do we go from O to M? The vector direction that we know right now are just these two. Talk to me. To go from, O to P and P to M, not it? R plus S, obvious, right? But I can say that. To go from O to M, part B. To go from O to M, based on the diagram, going along the vector direction that we know. We're going to go from O to P and then P to M. So the O to P is R plus S. I can just say R plus S. R up here, so S down there, so obvious, right? So you don't have to write this. R plus S. That is the vector OM. OM is that, right? Next part wants PX. PX. That's P to this. P to X. What do you think we're going to go from P to X? Remember, we know OX, guys. We know OX. Remember that the OX, part 2. Remember that the OX was 1/3 of the OM, don't it? And the OM is this, don't it? So the OX then is 1/3 of this, don't it? That's all? So the OX is therefore 1/3 of the part and 1/3 of the part there. So it's 1/3 of R and 1/3 of S. That is the OX. And what is the OP? So when you know the position vector, they can find these things. So if we go from P to X now, we can come down here so with a minus R, don't it? And then go to OX, don't it? Or because we know the position vector of each of them, we can use O on the last minus O on the first. See that? Good. So for part, this is part 1. Part 2 now, we can say the PX vector is OX minus OP. And the OX we said is this, right? 1/3 R plus 1/3 S minus the OP is R, right? OP is R, so you subtract the R. So that becomes 1/3 S and then a whole R, no, sorry, 1/3 R minus a whole R, give me negative 2/3 R, right? If you're not sure, you could write this R as 3/3. And then the 1 minus 3 is negative 2/3. Good? So anyway, I take it, it is minus 2/3. So this becomes minus 2/3 R. I would like to test these answers on a calculator. We like to test them if it is right. We like to test if this answer makes sense to take it from P to X. So this is saying to go from P to X, you must go 1/3 R and then 1/3 S and then minus 2/3 R, right? So let's see, let's look if it makes sense. What we say? 1/3 S minus 2/3 R. That's what we got. 1/3 S, yeah, minus 2/3 R. Let's see if it makes sense. Let's see if it makes sense. Let's use the, which color am I going to use now? Orange. All right, so when 1/3 of this S first, right? So I can break down this S into 3 equal parts and come into right here. That's 1/3. Right, there's 1/3, right? And then you must go 2/3 of this. So this now, this line now, if you break it down into 3 parts, like that, you want 2 of it. 2 of it is that length, don't it? Right? 2 of it is that length. So So we take this length, see if we can pick it up. Nope. Yes. And bring it here. Voila. See that? Beautiful. See? 1/3 S. See that work? 1/3 S and minus 2/3 R takes it from P to X. That is what you want. Always test the answers if it makes sense. So you can accept it. Get me? Get into the habit of doing that. All right, beautiful. Always check if it is right, if it makes sense. All right. So that part good. Next part wants QM. QM. So Q is here, M is here. QM. So talk to me now. How do we go from Q to M? Part 3. Q to M. Based on the diagram, how can we go from Q to M? Huh? What do you say? You have 1 million ways can go in. What would you do? What do you think? Look at what we have. What do we have? Let's write down what we have. Remember we said, look at what we have. Remember right over here what we have. Remember we said PX was this, right? Right? And the QX is 1/4 of PX, don't it? Do we have PX? Based on this equation. The Q, based on this equation right here, the XQ is 1/4 of the PX. No, so? Don't it? Right? So technically we have this, you know, just that we have it in the opposite direction, right? The XQ is 1/4 of the PX. Okay, we have the PX here. This is the PX. So the XQ is 1/4 of that, right? So, and remember also, you can also go Q to P if you want. Okay, remember the QP was 5. The QP is about talking now. Hey, you can go outside and talk, you know. Remember that we said that the PX was 5XQ, remember? So you have two options. You can come from Q all the way up to P, and then from P to M with the S, or you can come to X here and then go here, which is 2/3 of the OM. See that? 2/3 of the OM. So tell me which one you prefer. Let's do it both ways. More maths equals better maths. And see what we get. Tell you're gonna like this question. I know you're gonna like it. So let's do it 2 ways. We're gonna go Q to X and then X to M. See what we get doing it that way. We're gonna go Q to P and then go from P to M. So if we're gonna go from Q to P, we need to know what the vector PX is. No, it's not PX, PQ. Want to know the whole thing. Let me set it up for you up here, based on the diagram. Now remember that the PQ was 5XQ, don't it? Right? And the XQ is 1/4 of PX, don't it? So therefore the PQ is 5 times this thing. 5 times 1/4 PX. Why am I expressing in terms of PX? Why I think I'm expressing in terms of PX? Because we know PX down here, so. Because we know PX. Right? So this becomes that the PQ is 5/4 PX. Right? Just that now, we really have to be going in the opposite direction to go up to P. All right, this is method 1. So method 1, we're using method 1 first. So method 1 is to go from Q to P and then P to M, based on the diagram, right? But I say that, we're going to go Q to P and then P to M. Now the Q to P is really minus this. Because this is PQ we have now. That's PQ we have. So it's really minus PQ. So this is really minus PQ. This is minus PQ plus PM. And minus PQ means that it's minus 5 over 4 PX. Because PQ is this. So then minus 5 over 4 PX. So this becomes minus 5 over 4 PX plus PM. Right, this better. It's a plus. Let's put in the values now. So PX is this. So doing 5 over 4 of this, minus 5 over 4 of that. So negate this part and multiply by 5 over 4. It's going to become, multiply this times this. It's going to become 5 over 12 minus 5 over 12s. And then the minus 5 times this is going to become a plus. The 5 times 2 is 10 over 12R. And then the PM is just S on this diagram. So we're going to add S to this, plus S. Let's consolidate the values now. This is 10 over 12R. And then this minus this now is 7 over 12. I'm going to say 7 over 12. But this S is the same as 12 over 12. 12 minus 5 is 7. So we're getting 7 over 12S. So we're going to get plus 7 over 12S plus 7 over 12S. That's one answer we get. 10 over 12R plus 7 over 12S if we go from Q to P and then P to M. Let's try the other way now and see if we get the same answer. Instead now we're going to go from Q to X and then X to M. Let's do it that way, right? Let's do it that way now. Let's do it that way now. Maybe I should do it over this side so the diagram is in front of you. So the other method we're going to use to go from Q to M, to go from Q to M, we're going to go from Q to X, and then we're going to go from X to M. Now the Q to X, let's remind ourselves that we know XQ. See, the XQ is 1/4 of PX, right? But Q to X is the negative of this, right? It's the negative. That is XQ that we have. So QX, this QX is just minus XQ plus. Now XM is 2/3 of OM. But I get that? This XM is 2/3 of the OM, right? But I get that? Good. All right. So this minus XQ now becomes minus 1/4 PX, right? Minus X cubed is now minus this, minus 1/4 PX. This becomes minus 1/4 PX plus 2/3 of OM. Ready now? So 1/4 minus 1/4 PX means that we're taking minus 1/4 of this right now. So we're going to minus 1/4 of this term first, going to become minus 1/12S, and then minus 1/4 of this now, the minus becomes a plus, and then 1/4 of this becomes 2/12, 2/12 R. And then we're adding 2/3 of OM, but OM, remember, was just R plus S. So 2/3 of that becomes 2/3 of the R and 2/3 of the S. So you get 2/3 R, run the space. All right, okay. Plus 2/3 S. Let's consolidate the values now. Let's do what did we have down here? We had the R term first. Let's do the R term first. So adding these two R terms. Adding these two R terms. Can you see that these two R terms are going to become 10/12? Can I see it? Because this 2/3 is the same. You multiply this by 4 to get 12. I multiply this by 4 to get 8. So 2/3 same as 8/12. Now that these have the same denominator, we can add the numerator to become 10/12. But see that? Good, 10/12. So you get 10 over 12 S. See there? 10 over 12 R, 10 over 12 R. And then do the S terms now. S terms. This one again is same as 8 over 12 times by 4 to make it 12 times by 4 get 8. 8 minus this one is 7. See that? So again, the S becomes 7 over 12. See there? Plus 7 over 12S. Same answer as that one. So we can accept that answer because we do two different ways getting the same answer. But good. Question like them, I put in a special questions book and go work it. Put the question like this in the special questions book because it takes concentration and focus to do it. So you put questions like this in the special questions book and you work them over again. You can master these questions. You can be able to question them going nowadays. I'm going to shut it to quick and fast. Get me? But that is it. All right, so that is QM. But I go to that. Can I show you another way to do it still now? Well, I don't want to say another way to do it. I mix up on the brain, I teach you now. So we are ready. Yes, we are ready. I'll show you another way. No, go ahead. I'm going to show you another way. Let me show you another way. Let me show you another way. More maths equals better maths every time. Let's go. All right. I'm going to show you a method. Watch this now. So let's say I want to find QM, right? You would like to use OM minus OQ. Let's say I want to use that method. We know OM already, don't it? Right? Because OM, we found it first. It's just this, right? OM is this thing right here. So we know OM, right? What we don't know is OQ. So we don't know OQ. All right? So remember, to find OQ, we don't know OQ. We don't know OQ. We don't know OQ. Right? To find OQ, we can find an equation that has Q in it and pull it up and make OQ the subject. You get me? We have to teach you all the different skills now. So we're going to find an equation that has Q in it. Right? And that has other points in it with the position vector that we know. I want to pull it up. So the equation that we know with Q is this one right here that I gave us. See it here? Let me erase all of this. This guy that gave us, this has Q in it. And pull it up and make OQ the subject. And then once you find OQ, we can just use this. O times the last minus O times the first, right? All right? So let's take that equation and pull it up. So we're searching for OQ. Searching for OQ. For OQ. Trying to find OQ. That's what we don't know. I'm going to pull up this equation that they gave us. They told us this equation. They told us that PX is equal to 4XQ. And it's kind of easy because we know PX already, you know. We know PX. So it cannot so hard because we know PX. So it's easy to pull up and find OQ from this because we know PX for PX there. We have found PX before the axis for QM. We have PX already right here. So we can even use that to help us. So I'm going to take this equation and pull it up. And pluck out the OQ out of it. Copy, paste. I'm going to pull it up and find OQ out of it. Watch this now. Learn skills. You have to learn skills. So because I know this side already, I'm not going to pull up that side. I'm going to pull up this side alone. All right. In fact, let me move this quarter. Let me move this 4 and pull up that side there. All right. Do we know OX? Let me see if we know OX. Yes, we know OX. OX is 1/4 of OM. So we know OX too. Yeah. So you know what you need. You have all of it you need. You want to pull up it and get OQ out of it. So we can use it in another formula right here. So more maths equals better maths. So 1/4 PX is equal to XQ. Pull up this because we're trying to get OQ out of it. So 1/4 PX equals OQ minus OX. See that? To make OX a subject, we'll take this and transpose it over here. All right? So the OQ becomes 1/4 PX plus OX. 1/4 PX plus OX. That becomes the OQ. Right? Now 1/4 PX is 1/4 of this thing that we know already. So it's taking 1/4 of each part now. 1/4 of this becomes 1/12. 1/12 S, and 1/4 of the part here becomes 2/12 minus 2/12 R. That's what happens when I take 1/4 of this. Then now I want to add my OX. OX, remember, is 1/3 of OM. Remember? See it here? OX is 1/3 of OM. So OX is just this. 1/3 R plus 1/3 S. I'm going to add 1/3 R plus 1/3 S. So you see, I'm using a pure calculation method, not depending on the diagram now. I'm using pure calculation. Let's consolidate now. All right? So that's what this side becomes. This equal to OQ. Let's consolidate now, right here. So let's consolidate. Showing you a different method to do it. Put in the special questions book. All right, the S terms, this and this. Those are the S terms. All right. So this one is the same as 3/12. This one is the same as 4/12, don't it? Agreed? I'm going to say 4. It's easy now. Going like fractions hard. So multiply that one by 4/4. Forget 12 under this. So and multiply that one here by 3/3 to get 12 under this. So that one is the same as 3/12. That one is the same as 4/12. Come on, man. 4, 3, and 4 is 7. So it's 7/12 S dot. Don't it? Good. And then we're doing these two now. This one is same as 4/12. The 3/1/3 is same as 4/12. So the 4 minus this 2 is 2. So you're going to get plus 2/12 R. That is the OQ, you know. That is the OQ. 7/12. Good. So we know the OQ now. So I go back to now that more on QM. So the QM becomes OM minus OQ. So the OM, we have it already, it's just this, R plus S. So it's R plus S minus this. So you subtract the part and subtract the part there. See that? Subtract each part. Okay, you're subtracting OQ. So subtract the part there, you get minus 7/12 S, and subtract the part there, you get minus 2/12 R. And so you get, this is same as 12/12. 12 minus this 2 is 10. See that? 10/12 R. See that? This is 12/12. 12 minus 2 is 10. So you're getting 10/12. Let me put the 10/12 for now. This is same as 12/12. And this is same as 12/12 S. So 12 minus 2 is 10. So you're getting 10/12 R. And then 12 minus 7 is 5. So you get plus 5/12 S. What did we get down here, so? Something different. Some mistake made. So we're going to find it. A mistake make somewhere. Because we get, where did I make a mistake? Huh? What me have? Huh? Now what? Yes, sir? What is supposed to be? Oh, it's a quarter of this. Oh, it's a 12 it's supposed to be. Oh, it's 1/12. All right, thanks. Thanks. Tongues. Tongues. All right. Yes, a quarter of px. So the quarter of the part here become 1/12. Oh, I have 2, yes. And a quarter of this part became 2/12, right? So it's 1/12. Okay, all right. So this figure around. So in terms of this and this becomes, oh, it's 5. Yeah, this becomes 5. That becomes 5. That becomes 5. 5/12, because it's the same as 4/12. So that's 5/12. And so this is supposed to be a 5 I'm subtracting here. Good. Supposed to be a 5 I'm subtracting. And so this becomes the 7 that it's supposed to be. Yep, same answer. So the method I use here where I found the OQ. How I found it? Take an equation where I have a Q in it and pull it up and make OQ the subject. This method you don't need a diagram. Just straight calculation you use it. So you just find the equation that has Q in it and pull it up. The other method we use, look at the diagram and see how we go from point to point. That's the first 2 methods that we use. Just how we got there using 2 different parts, 2 different routes. The first route we use over here was one where we go up to P first and then came down to M. The second one, we came up to X and then go across to M. The other method, we use straight calculation. We look for the equation that has the Q in it and pull it up, pull it apart, and make OQ the subject. Then we use O time the last minus O time the first. It work itself out just the same. All right? We're not finished yet. I have another part. I'm not going. Question has one more part on it. It says, show that Pn is 2pm plus OP. Show that Pn is 2pm plus OP. Show that Pn. Question asks not about anything else. N out here, so. N out there, so. Pn is 2pm plus OP. 2pm plus OP. All right? So some calculation thing. Write it down here. So Pn is 2pm plus OP. All right. I think this is, we can use some pull-up method and do this. We can pull up the vectors and do it. Copy. I think we can pull up the vectors and do this one. Let's do it under here. That's what I want to show. This is what I want to show. All right. Let's start out with what Pn is based on the diagram. To go from P to N, we can go, or we go from P to N on this diagram. Talk to me. I would go O times the last minus O times the first, don't it? That's all?
But sir,
Yes.
an easier way to do it, since that M is the midpoint of ON, right?
Yes, sir. Yeah.
Wouldn't MN just be the same as ON?
Yes. Yes. Mn and OM is the same, yes.
So wouldn't you just find whatever, once you have whatever OM is, you just add that to PM?
Whatever OM is, just add, all right, let me see. So you are saying, talk it through, let me hear.
So sir,
Or somebody's online, so tell me, talk to me. So you say, talk to me. So Pn is the same as PM plus Mn, that's what you're saying?
yeah, and MN is the same as
Mn
OM.
is OM, right? So this is PM plus OM, yes. And then?
All right, so sir, if you put it down to the vectors themselves, it would be
And the
S.
OM is OP plus MN plus PM. So this OM, you're saying you're gonna have the PM here And then this OM is OP plus PM, don't it?
Yeah.
And then this and this make two of them, right?
Yes, sir.
You get 2 PM plus OP. Brilliant. Who said that?
Hmm?
Who is that talking?
Luke.
Very good. That's where it will work. But there are many ways to skin it. So what they did, he said, okay, look at the diagram and say, okay, we go from P to N. He said he could come down to M first and then use MN, right? But then he recognized that the MN is the same as OM, right? So the MN is the same as OM, which is true, right? And then now the OM is really this, OP plus PM. And so you really have 2 PM in there. PM and PM makes 2 PM plus back this OP. That works. Beautiful. See that? All right. So now but I with my way. Huh? We're okay with this one, with this way. Huh? We don't want to see my style. Look, you're flapping me, look. You flap me, look. They don't want to see my style. I'm not going to see my style. No, go ahead. ON. I would say, look at my method. I would say, look at my method now. Look at my method. So I'm saying to go from P, I'm using ON minus OP. Just to show you the beauty of vectors, right? Now this ON is 2 times OM. That's what I'm going to say. ON is 2 times OM. So I'm going to replace this with 2 OM minus OP. But then the OM is the same thing that we have here. It's OP plus PM. See? The OM is still OP plus PM. So this I'm going to replace with 2 times OP plus PM. And I'm subtracting back this OP. Let me take off this line. Right. So I'm subtracting back this OP. So this then becomes 2 OP plus 2 PM minus OP. So 2 OP minus OP gives you 1 OP. And so it still comes back to 2 PM plus OP. Same answer. So anyway, any method, I'm sure it can be done multiple other ways, several other ways it can be done. But that is it, guys. All right. Yeah, Luke, them say big up to you, Luke. The class say big up to you, Luke. All right, guys, that is it. So watch me now. All right, serious again. So I'm going to send the other page in the group. So remember from this paper, any question you didn't do, I know that I didn't do this one. So I'm not going to do it now for me, please. I'm going to send the video in the group right after. All right? Do the questions again by yourself for me, please. Put this vectors question in the special questions book. And when I send the next page, you should be able to work through the questions a lot easier now. Hey. Mr. Class is still never give me something. No talking at all. It's what I'm to the class here. Then we just make them alone come online. I want to stay home. Them come face to face. I want to stay home. You know, yeah, man, you can't do that for joke. I chat too much. All right. All right, guys. See you all Wednesday online. Remember, Wednesday online. Hey. Wednesday online for you. And Thursday face to face. All right. You basically attending every class to the holiday, you know. Every class you're attending to the holiday. Every class. So you're attending class Sunday, Monday, Wednesday, Thursday. Right, bye, everybody. Bye, everybody online.
Bye, sir.
All right, cool.
Bye, sir.
All right, bye-bye. Wow, you want to chat too much with you? I know say true too. Yeah, this one. All right, bye everybody.